far the best way to get good at multiple choice questions is to solve lots of them. Grab a pen and paper and let's solve. I have my digital pen and I am going to be talking you guys on how to approach every single one of those problems. So let's get into it. Question 1. An object is moving in a straight line. The displacement against time graph of the object is shown. At which point A, B, C or D does the object have the greatest speed? Okay, so speed is just the gradient in a displacement against time graph. So all you need to do is figure out where the gradient is the steepest. So this will be C, definitely the steepest part in this region. Okay, 2. Which one of the following prefixes represents the smallest multiplication factor? So femto is 10 to the power minus 15, micro 10 to the power minus 6, nano is 10 to the minus 9, pico is 10 to the power of minus 12. So correct answer is A. Okay, next one, 3. We have a table showing data for a car traveling on a straight road with an initial speed of 13 meters per second. We have our thinking distance, we have our braking distance and our stopping distance. The car has a constant deceleration when the brakes are applied. What is the magnitude of the deceleration of the car during braking? Okay, so what we're going to do is approach this problem using v squared is equal to u squared plus 2as. So we know that our braking distance is equal to 14. So this guy here will be 14. We need to figure out our acceleration. The initial speed, oh yeah, we do have the initial speed, which is 13, perfect. So the final speed will be 0, so 0 will be u squared plus 2as. This of course means that the acceleration will be given by minus u squared divided by 2s. So minus u squared is going to be minus 13 squared divided by 2 times 14. Let's put this into a calculator. So it'll be 13 squared divided by 2 times 14. So it's going to give me around 6.03 meters per second squared. Correct answer is C. Okay, next one. The freezing point of ethanol is 159 Kelvin. What is 159 Kelvin in degrees Celsius? It's actually kind of easy to get this question wrong. So remember, 0 Kelvin is around minus 273 degrees. So that means that 159 Kelvin will be given by minus 273 plus 159, and that's going to give me minus 114 degrees C. Correct answer is B. Okay, moving on. Question 5. We have a spectral line corresponding to a wavelength lambda 1 in the laboratory. The same spectral line observed in the spectrum of a receding galaxy corresponds to another wavelength lambda 2. The distance from the galaxy is d, the speed of light in a vacuum is c. What is the correct expression for the Hubble constant h0? Okay, well, we don't really have one equation for Hubble's constant, and that is that v is equal to h0, Hubble's constant, multiplied by the distance. This is a question about the Doppler effect, and we can link this to the Doppler effect using the fact that delta lambda over lambda is approximately equal to v over c, where this is the redshift, the fractional change in wavelength. Okay, so delta lambda is going to be lambda 2 take away lambda 1, and this lambda in the equation here is the wavelength as measured in the laboratory. So if I plug this expression for the speed into this part of the expression, I am going to get C, lambda 2, take away lambda 1, and then I'm going to be dividing that by lambda 1 is going to equal to the speed, which is h naught d, and then I can bring the factor of d here, which is going to give me, let's see, correct answer is A. Okay, next one. For a simple harmonic oscillator, the maximum speed is Vmax, where the amplitude is A. The frequency of the oscillation is F. What is the correct expression for this oscillator? Okay, well, we're given this formula that V is equal to plus or minus omega times the square root of A squared minus x squared. So when the simple harmonic oscillator is at its maximum speed, the displacement is actually zero. Kind of like a, let's say a pendulum is at its maximum speed when x is equal to 0 as it's oscillating. So this means that V is going to equal to plus or minus omega A, V max that is. K omega is 2 pi f, so this looks like it's going to be B, but let's just do a quick sanity check. This one, nope. This one, 4 pi squared f squared, nope. Yeah, correct answer is B. Okay, question 7. The planet Mercury has a highly elliptical orbit around the Sun. Gravitational force Mercury varies with distance r. The graph of F against r for Mercury and its orbit is shown. Okay, so it's a distance, it's a force against distance graph. Before even reading the rest of the question, I'm thinking that the area of force against distant graphs in all questions is equal to the work done, which is equal to the change of energy. In this case, this will be gravitational potential energy. Okay, what does the area under the graph represent? Okay, perfect. The question is about this already. So correct answer has got to be B, the change in GPE. Fantastic. Next question, question 8, which is all about vectors. An object of weight W is suspended from 2 identical cables. The tension in each cable is 2 newtons. So we have the angles. What is the weight of the object? Okay, so this here is kind of a classic setup. All we need to do is find the vertical component, because this 2 Newton force can be represented by a vector going up. Let's just draw that a little bit better. So vector going up, kind of like along here. But then the other one can also be represented by a vector along exactly the same place. Okay, so what is the horizontal? What is the vertical component? Excuse me. That will be 2.0 cos of 35. This here is the adjacent component, but there's 2 of them, so we're going to need to multiply that by 2. Quick check of the units, that's fine, just newtons. So 2 times cos 35 times 2. This is going to give me 3.27, around 3.3 newtons. Correct answer is D. Okay, let's move on. Question 9. A piston has a fixed amount of trapped ideal gas. The gas exerts pressure P and has volume V. The thermodynamic temperature is T, the mass is M, there are N atoms, we're given the Boltzmann's constant. What quantities are required to determine the root mean square speed of the atoms? So this question seems a little bit tricky, but all it's testing is actually our familiarity with the formula booklet. And there's an equation in there if you're doing OCR, which is that PV is equal to 1/3 NM and then C squared. Actually, yeah, if you're doing other exam boards, pretty much all of them do this equation. I think in AQA you also have to be able to derive it. Anyways, so PV is equal to 1/3 NM root mean will be multiplied by the square speed. Okay, well, so PV, N, and M are required because the third is just a third, so correct answer is D in this situation. Just testing our familiarity with the formula booklet. Okay, question 10. An object of mass 0.12 kg is lifted for a height of 0.6 meters at a constant speed of 3 meters per second. What is the minimum power to lift the object? Anytime I see power and I see speed, we can use that power is equal to force times velocity. So the force will just be essentially the weight. So what would that be? 0.12 multiplied by 9.81 multiplied by 3 meters per second. Once again, in the exam for the multiple choice, I would only use my calculator for this, rather wasting time writing these out. So 0.12 times 9.81 times 3.0, which is 3.53 watts. Correct answer is C. Now notice, because it's moving at a constant speed, this height, it doesn't really matter. It will still take in the same amount of joules per second. So they're trying to trick us by giving us a little bit of excess information. Okay, Kepler 90 is a star with several planets orbiting it. The two outermost planets are Kepler 90G and Kepler 90H. Kepler 90G has an orbital period of 210 days. And it's a certain distance from the center, given in astronomical units. Okay, what is the orbital period of the Kepler 90? Okay, so as soon as I'm reading this question, I know that pretty much I'm going to be using Kepler's third law. So Kepler's third law says that the square of the time period, so t squared, is proportional to, let me just write this a little bit better. It says that t squared is proportional to r cubed. Now this here means that t squared divided by r cubed will actually just be given by a constant. Because of that, we can write that t1 squared divided by r1 cubed will be given by t2 squared divided by r2 cubed. Okay, well, let's say that 90g is 1 and let's say that 90h is 2. Okay, so what we're looking for is the orbital period of 90h. So we're looking for t2. So t2 squared will be given by t1 squared over r1 cubed times r2 cubed. Because this is essentially going to be a ratio and we're looking for the orbital period in days, and the other one is also given in days, we don't have to worry about the units. What we do have to worry about though is making sure that we don't forget to square or cube, because this is actually really important. So this whole thing will be given by the square root, do not forget to square root this as well, of t1 squared, which is 210 days squared. Divide that by r1 cubed, so 90g was 1. Okay, Kepler 90g has an orbital period of 200 days, 0.71, so it's going to be divided by 0.71 cubed, and then I'm going to be multiplying that by r2 cubed, which is the orbital distance of 90h. Where is the orbital distance? 1.1. Okay, multiply by 1.1 cubed. Okay, well, let's put this into a calculator very carefully. So square root, what was the square root sign? There we go. And then 210 squared multiplied by 101 cubed divided by 0.71, then cubed. I guarantee that one of the options will involve just kind of simple things like forgetting to square root or forgetting the any of the cubes or the squares. Okay, so let's have a look. That gives me 356. Correct answer is C. I really enjoyed that question. Okay, moving on. Oscillations of an object can either be free or forced. Which of the following is an example of a forced oscillation. So a force has to be continuously applied, so a ball rolling to and from on a curved track. Nope, something displaced it, and then that made it roll. A loudspeaker oscillating and producing a continuous note. Absolutely, there is an electromagnetic force causing this that is continuously moving a speaker. So correct answer is definitely B. Okay, moving on. The force against extension graph of material being stretched is actually shown. What is the best estimate for the energy stored in the material when the extension is 10? Okay, now these ones here can actually be really tricky, and the area underneath the graph will give us the energy. However, because this is not a regular shape, if we were to try and estimate this with a triangle, that's like the worst line I've ever drawn. Let's try that again. But if we were to try and estimate that with a triangle, we're going to have a bit of a problem, because the area will be actually substantially bigger than that. So let's find the area of that triangle, which is just going to be a half times the base, which is 10 to the power of minus 3 millimeters. Oops, times 10 as well, because it's 10 millimeters. Half base times the height, which is in newtons, times 20. Okay, so what does that give me? 0.5 times 10 times 10 to the power minus 3 multiplied by 20. Okay, so that's just 0.1. But the answer is 0.1. It's going to be bigger than that. It's not going to be 0.2, because that's just the area of the entire rectangle. So it's going to be something between the area of the entire rectangle and 0.1, which is the area of the triangle. So this whole thing here has got to be somewhere, something in the middle. Correct answer has got to be C. Okay, moving on to the next one. We have a ball of mass m, which is falling vertically through the air. The total upward force on the ball is F. Okay, the force F is less than the weight of the object. The acceleration of free fall is G. What expression is correct for the acceleration of the ball? Okay, well, for that we're just going to use Newton's second law. So mass times acceleration. This here is our net force, and that's going to be equal to the weight of the ball, mg, and then F is acting in the opposite direction. What we're looking for here for the acceleration, okay, well, A will be given by mg, take away F divided by m, so what is that? G minus F over m. Okay, mg minus F divided by m. Okay, so this corresponds to this one. Correct answer is B. Okay, and then the last one, the parallax angle of a star is 0.015 seconds of an arc, or arc seconds. What is the distance in parsecs of the star as seen from Earth? Okay, so this one here is not so bad. I'm just going to use the fact that the distance is 1 over p, and we can directly apply this formula if we're dealing with the distance in parsecs and the parallax angle in arc seconds. So 1 over 0.015 will give me 200 over 3, which is around 67. Correct answer is A. Okay, next paper, we're definitely not done yet. Faraday's law of EM induction is written below with two terms missing. So that will be the induced EMF in a circuit is directly proportional to the rate of change of magnetic flux linkage. Really important. So correct answer has got to be D. Okay, next one. Monochromatic light from a laser is incident normally on a diffraction grating. Series of bright dots are formed on the distant screen. Which two terms can be used to explain these bright dots? Diffraction, interference, that seems very likely to be the answer. Reflection, interference, well, not really. No reflection. Refraction, nope, not refraction. So correct answer has got to be A. Okay, number 3, the current in a lamp is 2 milliamps. The potential difference across the lamp is 6 volts. What is the energy transfer in the lamp over a period of 3 hours? Okay, so energy transfer is given by VIT. Are we given the power in this case? No, we're given this, so it's going to be 6.0 multiplied by 2.0 times 10 to the power of minus 3 multiplied by 3 hours, so it's going to be 3 times 60 times 60, 3,600. Once again, don't write these out in multiple choice questions, just plug them straight into the calculator. So times 2.0 times 10 to the power of minus 3 times 3 times 3,600. So this here will give me around 130 joules. Correct answer is D. Okay, question 4. I've actually solved this one quite recently on a separate video. The diagram below shows 2 oppositely charged spheres. The magnitude of the charge on each sphere is the same. The point P is on the line joining the centers of the sphere, and it's the same distance from the center of each sphere. Which statement is correct? A negatively charged particle with P will move to the right. Well, if we put a negatively charged particle here, it's going to be attracted towards the positive and it will be repelled, so it's going to go this way. So A is definitely not correct, it will move to the left. The direction of the electric field at P is to the left. Well, let's have a look. So the electric fields go out of a positive charge, but they also go into a negative charge, so B is not correct. The electric potential at P is 0, yes, because it's just an algebraic quantity that's being added up. This here will be the correct answer, is C. D, the magnitude of the electric field strength at P is 0, is absolutely not correct, because they will be added up because they are in the same direction. With electric fields, we always need to look at the direction which they're going. If they're going the same direction, we have to add them up. So we have to think, because the electric field is just the force per unit charge. If I put like a little electron here or a little positive test charge, what force would it actually experience? Well, it's going to be repelled by this one, but also going to be attracted by this one. That's why the correct answer is C. The electric potential, actually, because it's a scalar, we just add the algebraic quantity, so that would just be minus q over 4 pi r squared plus q, oops, no square here, plus q over 4 pi r. There's a factor of epsilon naught here, but we just add those up and we get 0. Okay, cool, right, let's move on to okay, next one, we have a circuit with 4 LEDs, P, Q, R, and S, shown below. The trick about LEDs is that they always need to be connected positive to negative. I can immediately see that, well, Q is connected positive to negative, because if we trace, the current is gonna go around here. Well, this one here is not going to be connected. Actually, let me just be consistent. So this one here, P is connected the wrong way around, whereas this one is connected the right way around, which is positive to negative. Please don't confuse my X sign for, no, this one doesn't work. Let's change this actually. Okay, that's a bit better. Okay, so the current is going to go through there, but this means that ultimately this one here is going to be pointing the wrong way. If the current is connected this way, then this one here is also positive to negative, so this one here is fine, and that's it. So correct answer is D. Okay, next one, a student is modeling the decay of a charge of a capacitor discharging for a resistor, and they're given us the equation delta Q over delta T is minus 0.2 times the initial charge. So this is a modeling type of question. The student decides to use delta T is equal to 0.5 seconds. The initial charge on the capacitor is 1,000 microcoulombs. Okay, what is the value of Q in microcoulombs at T is equal to 1.5 seconds? Okay, so in order to get that, we need to fill out all of those individual columns, which is actually pretty easy. All I need to do, which I'll just write it out, is, well, we need to find our delta Q. So delta Q, just rearranging this equation, will be 0.2 Q, which is the initial charge, multiplied by delta T. I'm going to write out the first one, which is going to be minus 0.2 times 900. And then times delta T, which is 0.5 in this case. So let's write it out. So 0.2 times 900 times 0.5. It's going to give me a delta Q of 90. Okay, this means that we're going to have 810 left here. Now I'm going to repeat exactly the same process. However, rather than 900 here, I am going to write 810. And let's figure out our change in Q. 0.2 times 810 multiplied by 0.5. What does that give me? 81. Take those two away. 810, take away 81. That's going to give me 729. Correct answer C. Okay. Question 7. Let's have a look. We have a circuit with a thermistor that is shown below. The resistance of the thermistor is R, and the resistance of the thermistor is 2.5 R. So always useful to just do this. This one here is R, and the thermistor is 2.5 R. Okay, so this one here is kind of tricky. The first thing that I really want to find is the current I. So I know that the voltage across this one here is equal to 5 volts. So I can say that 5 volts is equal to I times the resistance across the thermistor, so times 2.5 R. So this means that the current will be given by 5 divided by 2.5 R, which is going to be just 2 divided by the resistance. Okay, so this here is the current. So this means that this voltage here is IR, so it's going to be 2 over R multiplied by the resistance. That's just I times R, which is the voltage, plus the voltage across this one here, which is, we know that one actually, which is 5. So what is that going to give me? This should give me just 7 volts. Correct answer is B. Perfect. Let's move on to the next one. A double slit is used in an interference experiment to independently investigate the light from two sources, K and L. The light from the sources have different wavelengths. The table shows some data. Light source, wavelength, separation, distance. What is the separation between adjacent bright fringes for source L? Okay, well, this here will be using the equation that the separation x is equal to, well, actually, the way it's given in the formula booklet is that lambda is equal to ax over d, meaning that x will be given by lambda d divided by a. Okay, so have we got the wavelength? So the wavelength is 0.8. and the distance has been halved. So basically the distance gives us a factor of 0.5 and the wavelength gives me a factor of 0.8. So is A kept the same? Okay, it appears so. So let's just add up those two numbers. So if the separation was 1.2 millimeters originally, let's multiply by 0.5 and then by 0.8, and we're going to get 0.48. meaning that the correct answer has got to be A. Essentially, before it was 1.2, but because x is proportional to lambda times d, we get a factor of 0.5 times 0.8, and well, this here is 0.48 millimeters. Correct answer is A. Okay, moving on to question number 9. A stationary wave is formed in a tube. The tube is closed on one end. The length of the tube is 3.5 meters. I actually solved this one recently in a separate video as well. Okay, so we're given that the length here is 3.5 meters, so this distance here is half a wavelength, this distance here is half a wavelength, so basically that distance here is one wavelength plus a quarter, so it's going to be 1.25 or 5 quarters. Lambda will be given by 3.5, and once again this distance here is basically a quarter of a wavelength, is equal to 3.5 meters. Okay, so that means that the wavelength lambda will be 3.5 times 4, divide that by 5, what would that give me? 3.5 times 4 divided by 5, that's going to be 2.8 meters. Frequency of the wave will be given by the speed of sound, which is 340 divided by the wavelength, 2.8. 340 divided by 2.8, that's going to give me 121 hertz. Correct answer is B. Okay, question 10, we're getting there, guys. A battery of EMF 6 volts and negligible internal resistance is used in the circuit below. The current from the battery is 30 milliamps. The current in the resistor X is 10 milliamps. Two resistors Y and Z are identical. What is the power dissipated in resistor Z? Okay, well, if there's 10 milliamps going down here, this means that there's got to be 20 milliamps kind of going through here, and what will the voltage be? Well, by Kirchhoff's second law, this here will be 6 volts, and those two together are going to be 6 volts. But each of them is going to have 3 volts, and then this one here will have 3 volts. Remember, Kirchhoff's second law says that the sum of the PDs is equal to the sum of the EMFs across a closed loop, and this here is one closed loop. So the power is equal to the voltage times the current. Voltage is 3 multiplied by 20 milliamps. That's going to be 60. Correct answer is B. Okay, moving on, the next one, question 11. The diagram below shows the graphs of displacement x against time for two waves S and T. The waves meet at a point in space. The superpositions of these two waves produces a resultant wave. What is the frequency F and the amplitude of the wave? Okay, well, shall we just have a look at the time period of this wave? So this here will just be our peak to peak distance. So what is that? Peak to peak, which is going to be 5 milliseconds. So 1 over 5.0 times 10 to the power of minus 3 will be the frequency. So let's put that into a calculator. 1 over 5.0 times 10 to the power of minus 3. That's going to give me 200 hertz. Okay, so the answer is either going to be C or D. Let's have a look at the actual amplitude. So the waves have the same frequency, but their amplitudes are opposite, so pretty much in antiphase. So we're going to have to take them away. One of them is 3, but the other one is negative, so it's minus 1. So what we need to do when we add them up is, well, we're going to get 2 millimeters. Correct answer is C. Okay, moving on. We have a flat coil with 200 turns and a cross-sectional area of around 1.2 times 10 to the power minus 4 meters squared. Okay, we have normal units here. The coil is placed horizontally in the uniform magnetic field. We have the flux density and the angle. What is the magnetic flux linkage of this coil? Okay, well, the magnetic flux linkage is going to be given by the number of turns times the flux density times the area times cosine theta. Number of turns is 200, multiply that by the flux density 0.050, multiplied by the area 1.2 times 10 to the power minus 4, and then multiply by the cos of the angle, which is 30 degrees. Double checking the angle as we should in multiple choice questions. It is the angle between the field lines and the normal to the surface, so they've given us the correct angle. Okay, if we put this into a calculator, we are going to get around 1.039 something times 10 to the power minus 3, and correct answer is D. Okay, next one. The nucleus of thorium-232 emits 2 alpha particles and 2 beta minus particles. Okay, so what is the nucleon number and the proton number for the nucleus of whatever is left? So emitting 2 alpha particles, each alpha particle, remember, has 2 protons and 2 neutrons, giving us a nucleon number of 4. So just after those 2 alpha particles, we are going to be left with some element X. Well, what will the numbers for this element X actually be? Okay, so we've lost 2 alpha particles, so this means that we've lost a total of 8 nucleons. So this number here will be 232, take away 8, what is that, 224. Now what we have down here is going to be 90, take away 2 times 2, which is going to give me 86. Now then, following that, we have beta minus decay. Now in beta minus decay, what we actually have is a neutron is going to turn into a proton, and in order to conserve charge, we're also going to get a beta minus particle, which is just an electron, and that electron will also come in with a little anti-electron neutrino. Okay, but the idea is that in this beta decay, this number up here, the nucleon number, remains the same because the total number of neutrons and protons remains the same. However, because a neutron has turned to a proton, we're going to get 2 more protons, i.e. this number here is going to turn to 88. So 224, 88, correct answer is A. Okay, moving on, 14. A beam of ultrasound is incident normally at the boundary between 2 soft tissues F and G. The table below shows some data on the 2 tissues. We've got the density of the tissue, and then we have the speed of ultrasound in that tissue. What percentage of the intensity of the ultrasound is reflected at the boundary? Okay, so to tackle this problem, we're going to use the fact that I are the reflected intensity over I naught. Well, this is actually the percentage of the reflected intensity at the boundary. Well, we need to multiply by 100 to get the percentage, but this thing is equal to Z1, take away Z2. All of this is squared over Z1 plus Z2 squared. Now I guarantee you that one of the answers will correspond to omitting the squares, which is an extremely common mistake that we need to be very much aware of. Okay, well, this thing here will be equal to rho c, take away. In my calculator, I'm going to times 1.2 times 1.5. Let's see what we get. 1.2 times 1.5. Okay, so this is just giving me 1.8 rho c squared. Then I'm going to be dividing that by rho c plus 1.8 rho c, all of it squared. Okay, well, this is essentially equal to minus 1.0.8 over or, well, because it's squared, actually we can get rid of the minus sign in a bit, so minus 0.8 rho c squared divided by 2.8 rho c squared. Those things are going to cancel, and what we're left with is 0.8 squared over 2.8 squared. Put that into a calculator, and this will correspond to 0.0819, which is around 8.2%. Correct answer is B. Okay, final one on this paper. Radiation detector is placed in front of a beta emitting source. Count rate is measured and recorded every 10 minutes. The results below are shown. 311, 309, 29. Okay, which term can be shown? Okay, it's definitely not exponential. It's definitely not linear, and it is definitely random. Correct answer is C. Now, just before we move on to the next one though, why is it not D? So spontaneous actually is not really applying to data. It just means that you cannot make it happen. You cannot make a radioactive material just decay out of nowhere and influence its activity. This is a term for data, and that is random. Let's do one more paper. After all, this is the ultimate guide to multiple choice questions, and we want to get as much practice as possible. So Archimedes Principle is written below with one word missing. The upthrust acting on an object in a fluid is equal to the weight of the fluid that's been displaced. Very, very important. Correct answer is D. Okay, 2. Which of the following is not a source of EMF? Chemical cell is, power supply is, solar cell is. B, light dependent resistor is not a source of EMF. 3, a student is explaining the photoelectric effect to his friend. Which statement is correct? An electron is emitted when the photon energy is greater than the threshold frequency. Well, this statement here is really just comparing energy with frequency, and we can't do that in physics. We have to compare things of the same units. Increasing the intensity increases the maximum kinetic energy of the emitted electrons. Absolutely no. There is a one-to-one interaction, so this does not happen. Photons are emitted from the metal during the photoelectric effect. Nope, it is electrons that are emitted, not photons. Mind you, you might argue that there is some infrared radiation being emitted, but I'm not going to go into that detail. By the process of elimination, D is the correct answer. Quick check, the energy of a photon is proportional to the frequency. Yep, correct answer D. Okay, next one. The air resistance F acting on an object falling vertically for the air is given by the expression F is equal to 0.13 v squared. What is the terminal velocity of the object? Okay, so a terminal velocity, you have mg, and you also have the drag force, in this case acting in the opposite way, and they are equal and opposite. Okay, so this will happen when F is equal to mg, which is going to be 0.13 v squared. Okay, so the v will be given by the square root, do not forget to square root, of 30 grams, which is going to be 30 times 10 to the power minus 3 kilograms, times 9.81 meters per second squared. Let's get rid of this unit for now. And so then we're going to be dividing that by the constant 0.13. Okay, let's put this into a calculator. Once again, do not forget to square root. One of the answers will likely be omitting the square root. So 30 times 10 to the power of minus 3 times 9.81. Divide that by 0.13. And this here will give me around 1.5 1.50 meters per second. Correct answer is C. 5. An object is traveling along a horizontal surface with a kinetic energy 16 joules and speed v. Okay, now this is probably a question which is going to have to be solved symbolically. So I'm going to say that when the kinetic energy is 16 joules, the speed is v. So I'm going to say that 16 is equal to a half mv squared. Okay, a force acts against the motion of the object. The work done by this force is 4 joules. What is the final speed of the object in terms of v? Okay, so the work done by this force is 4 joules. This means that there will be a change of energy which will be given by that amount. So this means that our final energy is going to be 12, and this will be given by a half mv final squared. Okay, now let's solve this system of equations. I'm going to find the mass on this side here, so I'm going to say that the mass is 16 times 2 is going to be 32 divided by v squared. That's right, isn't it? So yeah, mass will be 32 divided by v squared. Now let's plug that into here. What we're going to get is that 12 is equal to a half times the mass, which is 32 over v squared, where v is the initial speed, times the final speed squared. Okay, well, this here will be 16, so vf squared will be given by 12 over 16 v squared, and now I can just square root this to get this in terms of v. 12 over 16, putting that into a calculator, so square root of 12 over 16, what does that give me? 0.086. v. Correct answer is B, like so. Okay, next one, we have 4 electrical circuits are shown. All resistors are identical. Each circuit is connected to the same power supply. Which circuit dissipates the least power? Okay, so we want to minimize the power. This means that because p is equal to v squared divided by r at a constant PD, if the resistance is the highest, the power is going to be the lowest. The resistance will be the highest if we have as many components as possible in series, and this one here has the highest resistance, which is going to be 3R compared to all of them. So correct answer has got to be C. Okay, next one. A student investigates 4 different springs, A, B, C, and D. And we have some weight and the extension of the spring. All of the spring obey Hooke's law. Which spring has the largest elastic potential energy? Okay, well, E is equal to a half kx squared. Okay, well, we're not given k, but we know that also is going to be a half f times x. So we need the largest product of force times extension. So this one here, 2 times 5.2 is obviously just going to give me 10.4, so we can just write this down by the side. 4 times 4.6, this is going to be obviously a lot bigger, so that's going to be 18.4. Whichever that number is biggest will be the answer. 6 times 3.5, that's going to be 21. Oh, not 31, 21, which is a winner. Correct answer is C. Next one, which pair of quantities have the same SI base units? I think this question is already Oh no, different ones. So we have strain or elastic potential energy. Nope, strain is unitless. Strain and the force constant. Nope, once again strain is unitless. Stress is force per unit area, so that's going to be newtons per meter squared. The force constant K is equal to F over X, so it's going to be newtons per meter. So it's not that. Stress and Young's modulus is the correct answer. Young's modulus is defined as stress over strain. Strain is unitless, so they share the same units. Next one. Okay, next one, the number density of charge carriers in material X is around 10 to the power of 28 meters per meter cubed. The number density of charge carriers in another one is around 10 to the 5. Which row of the table correctly classifies both materials? Okay, now 10 to the 28 is a massive number, so it has to be a conductor. None of this, definitely not an insulator, it's definitely not a semiconductor as well. Correct answer has got to be A. Okay, 10. A resistance-wise part of an electrical circuit is shown below. Okay, the resistance of the wise pole, so it becomes longer and thinner. Okay, resistance is given by the resistivity, but resistance is proportional to the length divided by the cross-sectional area. If it becomes thinner, the area goes down, the resistance increases. If it becomes longer, the resistance increases yet again. Okay, so the resistance wire increases in resistance. Because of that, that's kind of our first step. Our second step is that the current does the opposite. So the current will in fact go down. Because the current goes down, that means that there's less current in the fixed resistor. So the fixed resistor's PD, that's equal to IR. R is, fixed, it cannot change, the current has gone down, therefore V fixed has gone down, therefore the voltmeter reading decreases. Correct answer is D. Okay, next one. Monochromatic light is incident on a double slit. We have a pattern of dark and bright fringes is formed. Which term together with diffraction can be used to explain these fringes? And the answer is A, interference. This one here is not so bad. Okay, 12. A cylinder of conducting material has length 6 times 10 to the power of minus 2 and a diameter of 2 times 10 to the power of minus 2. It has a resistance of 24 ohms. What is the resistivity of the material? Okay, remember that R is rho L over A. Therefore, the resistivity is given by RA divided by L, which is given by R times the area is going to be pi d over 2 squared divided by the length. Let's plug in some numbers. So it's going to be 24 times pi. Once again, these should be done on the calculator. I'm only writing them out just to showcase, because otherwise I'll just be talking. Diameter is 2.0 times 10 to the power of minus 2 divided by 2 squared. And let's divide that by the length, which is 6.0 times 10 to the power of minus 2. Okay, well, let's put some stuff into a calculator. So we're going to have 24 times pi times 2.0 divided by 2. So that's 1. That's essentially 10 to the power of minus 2 squared. Which is 10 to the power minus 4, divided by 6.0 times 10 to the power of minus 2 for the length, and we get an answer of pi over 25. What is that? 0.125. Correct answer is A. Okay, next one. A stationary wave is shown. The stationary wave shown before is formed on a stretched string. The frequency of this stationary wave is 72 Hertz. What is the fundamental frequency for a stationary wave on the same string? Okay, well, which harmonic is going to be this one? So on a stretched spring, our first harmonic is just half a wavelength because we have a condition that nodes need to be on both sides. Our second harmonic is at 1 full wavelength, and this one here is at 1.5 wavelengths. Okay, so 3 half wavelengths. They're all multiples of the fundamental. So if this one here is 72 Hertz, well, our fundamental will just be 72 divided by 3, which is 24 Hertz. Correct answer is B. Question 14. The de Broglie wavelength of a proton is 160 picometers. The kinetic energy of the proton is doubled. What is the de Broglie wavelength of the proton now? So there is a very useful formula that I remember, and you can derive it very quickly, but the kinetic energy of half mv squared is actually just p squared over 2m, where p is just the momentum, which is mass times velocity. Very, very useful formula. Okay, so kinetic energy is p squared over 2m. This means that the momentum is actually proportional to the square root of 2m multiplied by the kinetic energy. So the idea here is that if the kinetic energy doubles, so that increases by 2, then the momentum will increase by a factor of root 2. The de Broglie wavelength is inversely proportional to the momentum. So if the momentum increases by a factor of root 2, then the wavelength should decrease by a factor of root 2. So 160 divided by root 2, what does that give me? Around 113, up to 2 significant figures. That's going to be 110 picometers. Correct answer is B. Okay, 15. The displacement against time graph for a progressive wave is shown below. Which statement is correct about the phase difference phi between points X and Y? Okay, so the phase difference is between 0 and 90 degrees. Now remember, 90 degrees in this case, well, in all cases, is a quarter of a wavelength. Nope, this is definitely not true. It's a lot bigger than that. Quarter of a wavelength is basically just that, and that's just not true. It's also not exactly 90 degrees. It's not 180 degrees. It's going to be more than that, because 180 degrees is essentially half a wavelength. So if it was 180 degrees, for instance, this point here and this point here is at 180 degrees. So this means if it was this point here, will be at 180 degrees with sort of this point, but it's a little bit more than that, but it's also less than 270. Correct answer is D. Okay, next one. The energy of a photon is 2.5 eV. What is the principal radiation for this photon? Well, let's figure out what the wavelength is. So I'm going to say that E is equal to hc over lambda. Okay, lambda is equal to hc divided by E. Let's convert those to joules. So 6.63 times 10 to the power minus 34 times the speed of light, 3.0 times 10 to the power of 8. We're going to divide that by 2.5 times 1.6 times 10 to the power of minus 19. That is quite a lot of numbers. 6.63 times 10 to the power minus 34 multiplied by 3.0 times 10 to the power of 8 over 2.5 times 1.6 times 10 to the power of minus 19. Okay, so this is giving me 4.9 times 10 to the power of minus 7, which is 490 nanometers. This is visible light. Correct answer is C. Okay, 17. A student is recording results in a table. Which of the following is correct for the heading in the student's table in the value of stress written to 2 significant figures? Okay, so they want to record the value of 7,260,000 pascals. So the first one here doesn't seem correct because it's up to two significant figures. This is not 7,200,000, 7,300,000. So that's not the case. 730 kilopascals. So 730 kilo is 10 to the 3. That's missing a 0 because that's 730,000, not 7 million. And this one here also is 7.2. Correct answer is D, 7.3 times 10 to the power of 6. Okay, question 18. A bullet is fired at an angle of 30 degrees to the horizontal at a velocity of 200 meters per second. The bullet is in flight for a time t. Air resistance has a negligible effect on the motion of the bullet. What is the correct expression for the horizontal distance r that's been traveled by the bullet? Well, the horizontal range is just given by the expression, let's call it r, as in this question, and that's just the horizontal velocity times the time. Assuming there's no air resistance, the horizontal component remains exactly constant, so we can just use this equation. The horizontal component is just going to be 200 cosine 30, basically just this component here. So 200 cos 30 multiplied by the time. Correct answer is A. Okay, question 19. What can be deduced from the diffraction of electrons by graphite atoms? Okay, so if electrons are diffracted, this means that they show wave-like behavior. Correct answer is D. Okay, last one. Which one of the graphs below can be used to determine the impulse of a force from the area underneath the graph? Classic question. Anytime you have a force time graph, the area is given by the impulse, because impulse is given by force multiplied by area, or the average force multiplied by the time that it acts. Okay guys, hopefully this video was very useful. If you've gone for all these questions, well done, you deserve a rest. Amazing work. If not, have a look at this really common mistake in physics that will really help you get better and improve your grades right over here.